All right, so this is Calc 33.2, number 3. I'll do D was asked about. So we are trying to find, given the position functions, displacement is position function, find the velocity and acceleration as functions of time. So again, velocity is first derivative, acceleration second derivative. So for D, the first derivative is s prime, or the velocity function here. So if you want to write it like that. So we have, let's write this as t squared plus t to the power of 1/2. It's going to make things a little bit easier when you do the power rule. So that's going to be 1/2 t squared plus t to the negative 1/2, right? Now also we have to multiply by, you have to chain rule because there's a function inside. So this is going to be times 2t plus 1. Okay? So we've got this for our velocity function. If you want to leave it as a product, you can with the negative exponent. If you want to write it like this, it's going to be 2t plus 1 over 2 root t squared plus t. So that might be, that's the more reasonable way probably to write it, to look at it. Now, any questions about that? Velocity function, you got that part? Okay. So second derivative, obviously we have to do quotient rule. We got a root in there, so it's going to be a bit of a longer process. But the acceleration function, and just a little a for acceleration, just like little v for velocity, little a for acceleration is fine, which is the second derivative. So it's the derivative of the derivative. So the derivative of the top is 2 times the bottom. Okay, derivative of the top times the bottom minus the top, 2t plus 1, times the derivative of the bottom, which, I'm going to run out of room here. So is the derivative of the bottom is going to be, can I do a couple things in a row here? Can I do like the 1/2 times 2 is just 1? Okay, so that's going to be t squared plus t to the negative 1/2. Okay, so the derivative of the top times the bottom minus the top times the derivative of the bottom. Now I got to do my chain rule, I guess. 2t plus 1 all over the bottom squared. So the bottom squared is going to be 2 times 2 is 4, and this squared, the square root squared, is just going to be t squared plus t. Does that look okay? So you can do that little simplification as you go there. Okay. Oh, I have a note here about this question, about this D, saying that there might be an issue here. So if you looked in the answer key and didn't find the same answer, there might be an issue there. We'll see. Okay, so to simplify this now, you were asked in your previous assignments to simplify stuff like this. So what we have to remember is that this negative here means that we have a little denominator in this term, right? So let's see here. This is going to be 4 root t squared plus t. We're going to be subtracting. Now, a secondary set of brackets might be appropriate, but we're going to be subtracting. This is going to be 2t plus 1, looks like squared over root t squared plus t. Does that look right? Okay. So when you write it like this, it's kind of a little more obvious to see that, hey, I need to simplify this by subtracting what's up there, but I need a common denominator, so I'm going to do root t squared plus t, and I'm going to multiply the top by root t squared plus t as well, which is going to eliminate these square roots, really. So I'll just change color in case they get close. So what have I got here? Now I've got 4 times t squared plus t. I've got minus, what have I got over here? 2t plus 1 all squared. And all of this is over root t squared plus t. Now if all of it is over the same denominator and I have another denominator, I can write that as a product down there, right? So I'm going to go 4 times t squared plus t times this root t squared plus t. Everyone see what I did there? Take this common denominator and just shove it down as a factor in the denominator that's already given. You can do that. Now, we have the same expression here. This is to the power of 1. This t squared plus t is really to the power of 1/2 here, right? So if we have the same base multiplied together with another term that's has the same base, then we can just add the exponents. So let me just see here, would this be appropriate? I can't pull a common factor out of all these terms. I have a t squared plus t here and here, but I don't have one over here, sadly. So I can't just pull one out. I can't simplify it that way by the looks of it, but I can combine this a little bit. So, and I'll expand all this, see if I can maybe gather some like terms. So let's just leave the factoring down there at the bottom for now. Let's do 4t squared plus 4t. This is going to be minus, what's this expanded out? That's 4t squared plus 4t plus 1, when you expand all that out. Okay. Okay. Recopy kind of what you're not touching there so you can kind of see everything. Gives you a little bit of time too to just examine if you've done everything right. So can I combine some like terms up top there? Yeah, it looks like these t squareds are gone. It looks like these t's, 4t's are gone. So what do I have? I have a -1. So I have a -1 over. This is going to be 4. And again, 1 plus 1/2 is this to the power of 3 over 2. Or root t squared plus t all cubed. Do you see how this is square root? Also, it also equals this with the cubed inside. So that's kind of a rule. The denominator of the fractional exponent is the index of the root. And then this number in the numerator is sort of the just the regular exponent there. So that's how I did that. Now, let me just see here. Yeah, that's exactly what I had before. I don't know where this. Okay, I've got a little note like something's wrong, but I think I got the same as. Yeah. Now, is there a question about evaluating? No.
No.
Okay. So yeah, I think this is your velocity function right here. Looks to be perfectly correct. And then, yeah, this is what I got here before too, looks like. Good. Any questions? No questions? Okay. Okay, so that's 3D there, 3.2 3D. All of your hopes and dreams are now secured that you know that question. You won't end up in jail now. Now you want to end up in jail. This is really why I'm teaching you this, so you don't end up in jail.
So I don't end up in jail.
Yeah.
Yes.
Nice.